Welcome to the second part of this Love2D and Lua car controller tutorial. Last time we got some basic steering and movement, and now I'll show you how to constrain the movement to be more car-like. First, let's prevent the car from turning in place while motionless. Well, the problem is we don't want the car to be able to turn when its scalar speed is 0, and also, if it's a little above 0, we don't want the car to be able to turn at 100% of its turn speed. What we want is some kind of percentage value between like 0 and a threshold. If it's at the threshold value, it's going to be able to turn 100%. But if it's below that, it's going to be a percentage. And also, we don't want it to be able to exceed that percentage. We don't want it to be able to turn at 200% of its turn speed. So how are we going to do that? Well, maybe you have some idea. We're going to need to create some kind of percentage value. Let's do that right now. So I'm going to do that. I'm going to create an arbitrary value called max turn, and that's going to be 100. So once it hits 100, it's going to be able to move at 100. It's going to be able to turn at 100%. And this is just a random value. It doesn't matter. This is just something I thought works well. And then I'm going to have a turn percentage, which is going to be the current speed divided by max turn. So just think about how this works. When current speed is 100, this is going to be 1. When it's 0, it's going to be 0. And we are getting a percentage. But we don't want current speed to be like 1.5, or we don't want this to exceed 100 and be like 150 or 200. So we need to clamp this value. And we can do that with math.min 1. And there we go. Now, if you've never used math.min before, or min or max, what this is saying is, use whichever value is lower. So if this is higher than 1, use 1. If it's lower than 1, use this value. Okay. That's all well and good, but there's one problem. We don't know the current speed. So, we actually need to move this. So I'm going to move this down here, and we're going to get the current speed. And for that, we're going to need the current velocity. So I'll call it vel x, vel y is equal to self.body get linear velocity. That just gets the current velocity, no matter what it is. Has nothing to do with input. And there's one other problem. We need the scalar speed, not the velocity. Well, what is the speed exactly? How do we get a speed from a velocity? Well, if you remember your vector maths, you know that the distance of a vector, or the length of a vector, can be found by square rooting x squared plus y squared. Right? Because that's Pythagoras' theorem. So we want to get the length of the velocity because velocity is a vector, and that will give us our scalar speed. But right now we need a helper function for that. Or actually, you know what? We don't really need a helper function. I can just do it right here. So I'm going to do local current speed equals math.square root. And I'm going to do vel x times vel x plus vel y times vel y. Okay, so we're getting the length of this vector, and that's going to give us our speed. Okay, I think we have everything we need here, but we just need to take this turn percentage and apply it. So here we have where we're using the turn speed, and we're going to multiply it by that percentage. Alright, so just think about this from an intuitive level, if turn percentage is 0, it's going to be 0% of the turn speed. It's going to be 0. Nothing will happen. If it's 0.5, half, it's going to be half of the turn speed. Alright, so that should work. Let's see how it looks. Okay, I am pressing the turn keys and nothing's happening. So let's give it a little bit of gas. So I move a little bit and I can turn a little bit. And if I move a lot, I can actually turn at full turn speed. Because once I hit 100, I can move at 100% of the turn speed. But if I stop, I can't turn, or I can, just turn very little until I come to a full stop. Okay, great. So the last thing we need to handle is the drifting. Now we come to the part of the tutorial I was dreading the most. Warning, there's going to be a lot of vector math ahead. To stop the car from drifting sideways, we need to apply an impulse that's in the opposite direction of the car's lateral or sideways velocity, and then multiply that by the car's mass. An impulse in Box 2D is just a sudden push to the rigid body. But first we need to get the sideways velocity. And to do that, we need to project the velocity onto the car's right vector. Now, when I said project, if you thought of the dot product, you're right. Now, I did not come up with this idea. Full credit goes to iForce2D.net. I certainly recommend reading this article. Anyways, I went ahead and created this helper function. It's not part of our car class, but what it does is it just gets a dot product. And if you didn't know already, you get the dot product with one vector's x multiplied by another's plus a y multiplied by the other's y. Okay, so let's get our lateral velocity, and I'll create a new function. I'll call it car get lateral velocity. And to get the lateral velocity, we need the right side vector, the right normal of the car. Well, we know how to get the forward vector. We use this function, getWorldVector. So to get the right side vector, I'll do local right x, right y equals self.body getWorldVector, and this time it'll be x, so 1 and 0. That gives us the right side. Now we'll get the dot product. Well, to get the dot product, we need the velocity. And if you remember, we actually have our velocity right down here. So we'll pass that in. Vel x, vel y. And we'll get the dot product of that using the right and then the velocity. So that gives us our projection. Oops. Something's not right here. Oh, this has to be, equals dot product. So that gives us the scalar value of the sideways velocity. But we need a direction for velocity, right? Because we need a direction to push against our velocity. So that's going to be the inverse of the sideways velocity. So what we're going to do is return dot times the negative right x, and then dot times the negative right y. Actually, you know what? I'm not gonna invert it here because you might want to use the lateral velocity for some other purpose. So I'm just gonna return that. So I'm returning a new vector. So this right here is going to be our sideways velocity. Okay. And now we need to create an impulse. So as I said before, the impulse is going to push against the sideways velocity, and it's essentially going to cancel it out, so the car won't drift, or won't drift as much. So to do that, now what we can do is we can create an impulse here. That is going to equal self get lateral velocity. And we'll pass in the velocity. Okay. And we'll take that. And we'll multiply it by -1 to invert it. And then that's not all, we'll also multiply it against the mass. So self.body get mass. And we'll do the same thing for the other one. Okay, so now we have to apply the impulse. So self.body apply linear impulse. And we'll do impulse X, impulse Y. We could leave it like that, but what I'd like to do is apply that against the center of the body. So I'm going to do self.body get world center. Okay. Now this returns a vector value, so it returns an X and a Y value. But the way Lua works is when you return a function with multiple returns, it actually gets used in each argument. So if there's two arguments here, and this returns two variables, it's actually going to get used inside, just as it is. So that's fine. I'm going to save that, and I think it should work. Let's see. And I'm moving, and I don't appear to be drifting. Okay, it's good. It's now looking less like a spaceship and more like a car. Okay, great. I want to see what it looks like with the background. I'm going to go back here and turn on the background. Okay. Well, a little hard to control, but very nice. I mean, I hope you enjoyed this tutorial. I know there's like a lot of math stuff, and you know, we have to use a lot of functions to really get to this point, but considering like how there are not a lot of tutorials on this subject, I thought it would be very useful to make this. And now you have a car controller that you can use in a top-down car game like Grand Theft Auto 2 or something. Okay, maybe later on I'll show you how to refine this even further, like adjust the drag so it drags a little bit, and you know, be able to change the direction when you reverse. But yeah, we now have like a perfectly serviceable car controller. If you thought this was valuable to you, like and subscribe. Thank you very much.